Right. Good morning, Solomon. Uh, you guys hear me?
Yeah, I can hear you very, very much.
Okay. Right. Okay. Now today is the day 4. How about the last day? Were you able to implement the things last day? Could you able to finish the implementation
Um,
about?
no, not really. Yeah,
Uh,
yeah.
you you try to implement that one, and if you have any difficulties, let me know so I
Okay.
can help you.
Oh,
Right.
okay.
Okay. So we'll move to our today's lesson. That is related to tensors. Tensors. Actually, what is this tensor? Now, you may, since you have done chemistry, you have, you may also have done physics and mathematics as well, I believe. Those days, you have learned something called vectors, and in your high school learning
Yeah,
stages. Yeah.
vectors and
So
matrices.
yeah. This is beyond that one. So the vectors normally it is a mathematical defined as in those days you have learned it as vector is a quantity which has both magnitude and direction. Is that so? And
Yeah,
the scalar is just a magnitude which does not have a direction. But that definition is very basic one, and the real definition is coming with the mathematical implementation to that one. So that definition actually comes from the tensors, and the mathematical way of defining tensors and the way of defining in the machine learning is quite different, but actually the content is the same. So in machine learning, tensors means actually it is a data structure. Data structure means it is a method of storing data. Now, guys, uh, we are uh, we are dealing with data in the machine learning domain because machine learning comes under the data science. So we will be dealing with data, and we should have a mechanism to store these data as well. Okay, there are different types of data storing mechanisms. Those things we call as data structures, the way of storing data. Okay, this tensor is a one way of storing data, and this is the normally the uh, basic data structure in the machine learning domain. In the machine learning, we will be learning uh, uh, we will be dealing with some kind of libraries called scikit-learn. And in the deep learning, we will be dealing with TensorFlows. Okay, those are the libraries, the Python libraries that we are associating with. So the all of those libraries are using these tensor data structures to store their data. The mainly these tensors are storing numbers. You can store the characters as well. Characters means the, the anything which has one unique value. Like number is also a character you can consider. And if the alphabetical alphanumerical things also you can consider as characters. Simple A, capital A, like that way. The uh, uh, alphabetical things also we can consider as characters. So 90% of the uh, things but we are storing on the tensors are numbers, and the rest of the 10% will be the characters. Okay, then the tensors, that is the first thing. The first thing is tensor is basically it is a data structure which can be used to store numbers. The second thing, there are some kind of classifications in the tensors. Uh, as I told, in your high school stages, you have learned vectors and scalars. Those are also comes under the what we call tensors. So the first thing what we are learning under the tensors is the scalars. Okay, we will be learning something called scalars. Okay, so now we will be seeing what is this machine learning domain for this scalars. Okay, if we store a number like a single number like 234 or anything like 100 or 1000 or 100,000, but just a one number, we can consider it as a scalar. Okay, the specialty of this scalar is it does not have a dimension. Okay, we will be seeing what is the meaning of this one. Okay, I will use this thing. Right now, according to this one, I have used a Google Colab, or you can use Jupyter Notebook, and I have imported this library called the Numpy library. Numpy is a library which is associated with arrays. Okay, so I have assigned a variable called a, and np is the abbreviation for the numpy, np.array, and I have taken just a number 2. Okay, now I want to store 2. So if I then give this one, I have got array like this way 2. Now if I want to check the dimension of this one, okay, I want to use this command called ndim. NDIM stands for number of dimensions, and I got the answer as 0. This means the number of dimension of the scalar is 0. Number of dimensions means it is actually the axis, or you can consider as it is the direction. So according to this one, the direction of this one is 0. Okay, that's why we are calling it as a scalar. This has a magnitude. That magnitude is 2, but it does not have a direction. That's why we got the answer as 0. So we'll see and we'll do the implementation, and we'll figure out what are the things we can do. So I'm going to the Google Colab, and see how do we go to Google Colab. Just put Google Colab, the Google. Now take this Google. Welcome to Collaboratory, Google Research. And I thought of now, Solomon, to make you easy for these things. Okay, especially you want to go with the implementations as well. So I want to do what we call the deep learning, because you want to go mainly with the deep learning as well. So while continuing with this lesson, I want to do a small implementation and explain you how the deep learning libraries are working and how do we do implementation using deep learning as well. Okay.
Okay.
So then during this week, I thought of you want to have the convolutional neural network. Okay, you want to have that knowledge. You told me like that, isn't it?
Yeah.
We'll do a small implementation related to convolutional neural network. Then you can continue your research according to that.
Okay.
Right.
Thank you so much. Yeah.
Okay. Right. We'll first import numpy as np and put shift enter. Okay. Then I will be storing something called under this a, np is the numpy dot array, and I will give a number called 2 or anything. I just put 10. Okay, shift enter. Then put a and c. How is the execution of that one? Now they have stored the number which is called the 10. Now After that, I want to check what is the dimension of this one. So A dot NDIM. Even these are very short, what we call coding parts. You have to just have the hands-on experience. Then only you will get this idea. Okay, so you get the answer 0. You get the answer 0. 0 means this does not have a dimension. This does not have a dimension means actually this does not have axis. This has a number but does not have a dimension. That means it is a scalar. Okay, so this is the actually the mathematical meaning of what is a scalar. Okay, we know that in the high school days, we know that scalar does not have a direction. How that direction does not have, what is the meaning of it does not have a direction? That means it does not have a dimension. Then this is the mathematical meaning of does not have a dimension. That means does not have a direction. I believe that you point, isn't it? Is that clear?
Yes, clear.
Now we'll move to the vectors. Okay, vectors, we know that vectors has a direction. Okay, we'll see what is that. What is the meaning of vectors as a direction? Okay, right. This thing we'll call vectors as 1D tensors. The scalars as 0D tensors. Vectors as 1D tensors. Okay, vectors actually it is a collection of scalars. Collection of scalars means now according to the scalars we have just taken one number, but here we will be taking collection of numbers and we will be writing those collection as a list, Python list. You can see here I have taken a list of numbers. List normally represented by under under these type of square brackets and as a sequence of numbers. Now this 1, 2, 3, 4 is a sequence of numbers and those are included inside of square brackets. This type of container we can consider as a list. Okay, so ARR is just a variable we have used to store these numbers. So ARR equals np.array and this collection of or the list of numbers. So if you put this ARR, then you got this list like this way, 1, 2, 3, 4 array list. And if you want to check about the dimension of this one, you will get it as you have to give the command arr.ndi. ARR is the variable. So you get the answer as 1. 1 means it has a one axis, one tensor axis. One tensor axis means it has unique direction, one direction. Okay, so that it give you the idea that vectors has a direction. Okay, we'll code that one as well here. So what I'm going to do, I will take a variable ARR or anything you can put. Okay. Now you are going to give a list of numbers. So numpy we will be putting np dot array, and as a list you can put the numbers 1, 2, 3, 4. Okay, good. Shift and enter. Then ARR, get the answer like this way. And now check ARR.ndim. Shift enter. Got the answer as 1. This 1 means it has one axis of one dimension. That means this has a direction. Okay, now this is your vector. Vector means it is a collection of numbers, collections of scalars, collections of numbers. Okay, collections of scalars or collections of numbers. Okay, so guys, now vector is generated as a collection of scalars. Okay, now here this vectors has 4 components, isn't it? 4, because 1, 2, 3, 4 are the 4 components. Here you can say the dimension of the vector is 4. because it has 4 values. Earlier, the dimension of scalar, okay, the scalar, we told that it does not have a dimension because it is just a one number. But it has, okay, 4 things. Okay, if you want to consider about the size of the vector, or you can consider the size dimension of the vector, it is 4. But the dimension of the tensor is 1. This is vector means 1D tensor, and it has only one dimension, tensor. And believe that you got that one as well. Okay, so this is a 1D array or 1D tensor. Vector means 1D array or 1D tensor. But in this vector, it has 4 elements. It has 4 elements. Because of that, you can say that the dimension of the vector is 4. The dimension of the vector is 4. And we will call the number of axes as the dimension number. Or you can give another name called rank. Number of axes or the rank or the dimension is the same meaning. Okay. Vector has 1 axis because you got the answer as 1. Okay, if you get like this way list, you can see here, this is 2 numbers. Because of that, vector dimension is 2 here, vector dimension. But what is the tensor dimension? This is just a vector. Vector means it is 1 dimension. Okay, so you can say this is a 1D tensor. 1D tensor means it is a vector. What is the dimension of the vector? It has 2 components. Because of that, it is 2D. Did you get my point?
So it has a and y, that's 2 dimension.
Yeah.
It's 3 x, y, z.
Yeah, very good. X, Y. If it is a 2, vector dimension is 2 means it is X, Y. If it is vector dimension is 3 means you will be getting X, Y, Z. Did you get my point?
Yeah, sure.
Right. Then 2D tensors. Okay, 2D tensors, we'll call it as the matrices. Okay, matrices. Here, now again, come to the previous stages. Collection of scalars is a vector. Now, this matrices means it is a collection of vectors. Collection of scalars is a vector. Collection of vectors is a matrix. Okay, we'll see how this thing is happening. Collection of multiple vectors is a matrix. Now, we have represented a vector as a list. So, if we consider collection of lists, then we can consider it as a matrix. So it is like that: 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9. And now these are 3 arrays. But you have to put all of those things in a one collection. So we will consider it as a 2D array. It is like this way: 1, 2, 3, 4, 5, 6, 7, 8, 9 separated lists. Those separated lists, again, you want to put it a container that is called the 2D array. That is called the matrix. This MAT for the variable name of the matrix. Matrix equals np.array, and you will be having collection of what are these vectors, collection of vectors. So since it is a collection of these things, now this is one square bracket, this is another one, and all together you want to put it as a one container. That's why we are putting another square. That means it is a 2D array. If you execute this one, you will be getting it like this way. Now 1, 2, 3, this is a one list, another list, another list. That means it's a collection of lists. So this collection of lists we will be calling as what we call matrix. And if you get the dimension of this one, mat.ndm, you will be getting it as 2. What do you mean by this 2? You can see in a matrix, you can see a row number this way. The horizontal direction, it is a row. And the vertical direction, it is what? Columns. Okay, that's two axes. One axis is the row axis, and the other axis is the column axis. That's why you got the answer as 2. We'll execute that thing as well. Okay, I will be taking variable as mat, mat, and np.array, and you use 2D arrays because you have to consider these containers, right? I'll take 1, 2, 3, and here another list 4, 5, 6, another list, take it as here 7, 8, 9. If you get it like this way and shift enter and mat, you will be getting this thing. Okay, if you want to get the ndim, number of dimensions, shift enter, you got the answer as 2. 2 means this is the row. Row means the first thing, and the column is the another one. How many rows here? 3. How many columns here? 3. So here you can say 3 by 3. The first 3 is for the row number, second 3 is for the column number. That's why you got here as 2. Okay, rank or the NDIM. NDIM means number of dimensions is 2. The rank also another name for the number of dimensions. Okay, now we'll consider about ND tensors. ND tensors means multi-dimension tensors. First, when we consider about the multi-dimension tensors, we'll consider about the 3D tensor. Okay, again go to the beginning. Collection of scalars is a vector. Collections of vectors is a matrix. Now what is that? 2D vector, 2D dimension means 2D tensor means it is a vector. Sorry, 2D tensor means it is a matrix. Matrix is a collection of 1D tensors, and now here 3D tensors. So what is that? 3D tensor is a collection of 2D tensors. Okay, we'll see. 2D tensor is a matrix. You can see the matrix here. And collection of matrices. So you basically matrix is, you can consider it as a one plane. Okay. So what you should have as the collection of matrices, you have to have parallel matrices or some number of matrices. This is the first matrix, and you will be having another matrix. Like that way you can have number of matrices. Okay, since if you consider about one matrix, it has the rows and the columns only. Now, when you consider about collection of matrices, you have to consider about this depth as well. Okay, this direction also you want to consider, because along that direction you will be getting more matrices. Okay, then only you will be getting this collection of matrices. Okay, therefore, the earlier in the 2D dimension, you will get only the rows and the columns. But here, with that, you will be getting this depth as well. So here now, this depth means how many matrices are available. Here I have just drawn 4. So that number of matrices is 4 here. Then this 3 and 3 means the number of rows and number of columns. So according to this way, it is now a 3D tensor. Again, 3D tensor means it is a collection of 2D tensors. What we had in 2D tensors, just the rows and columns. But here, you will be having collection of 2D tensors. So you will be getting what are the available 2D tensors. So here I have 4. So you have to include this 4 as well. If that thing also comes here, it will be coming as another dimension, because it will be coming in this direction. So 4 into 3 into 3. So now it is a 3D tensor. Did you get that idea? How about that? Any question? Okay.
I got it.
Right. Then we'll discuss about the 4D tensor. Okay, now again, 3D tensor means a collection of 2D tensors. Now 4D tensors means the same thing, but is a collection of 3D tensors. Now here you have seen 3D tensors means it is like the cuboid, because you can have like this way, and this way. So that means it is like a cuboid. So 3D tensor means it is like a cuboid. So what is then 4D tensor? It is a collection of cuboids. Okay. 3D tensor is like a cuboid. Then what is a 4D tensor? It is a collection of cuboids. So it will be like this way. Okay. Cuboids. So vector of 3D tensors. We can consider it as a vector of 3D tensors. That means list of 3D tensors. Or you can say it is a collection of cuboids. 3D tensor is a cuboid. It is 3D tensor means one cuboid. Now it is a collection of cuboids. That's a 4D tensor. Right. Then we'll see 5D tensor. You can understand now. This is for 4D tensor. Then when you move to the 5D tensor, you should have collection of these 4D tensors. So how do you have the collection of 4D tensor? This is one. This is a 4D tensor. You have to have these type of collection. So below to this one, you will be having a set of cuboid. Above to this one, you will be having set of cuboids. Like that way, you will be having collection of 4D tensors. So it will be like this way. I have only drawn two lists like this way, but you can have more. So then this is what 5D tensor. The same manner, how do we get the 6D? Now you can see these collections are in just imagine a wall, and you will have just imagine a cabinet. Okay, you have included these cuboids in a cabinet, the racks of the cabinets, rack of that cabinet. Okay, yeah. So how can you have then 6D tensor? 5D tensor is like one cabinet, and you will be included the cuboids, these cuboids in the rack of that cabinet. Now, if you are having multiple cabinets parallel to that one, so you can say it is like a 6D tensor. That means like this way is available for 5D tensor. The same set, if you are having parallelly, you can say it is a 6D tensor. Have you got that idea? 6D tensor.
Yeah.
Right. So in here only then if you want to consider about the 7D tensor, the same thing is repeated. Okay. It will be again as a big list, like that it will be going. So then in according to machine learning examples, it is limited up to 5D tensors. Okay, you want to know the examples up to 5D tensors. So before to move to the examples, we learn something called rank, axis, and the shape. Okay, the shape, the rank means the number of axes or the number of dimensions available in a tensor, number of dimensions or number of axes. In a scalar, 0, vector 1. Okay, 2D, 2D means it will be what? 2. 3D means 3, like that it will be going. Now this is a matrix. Matrix, you have to put the row number and the column number. By representing this way row number, the dimensions, we'll be calling it as the shape of the tensor. Shape means you are showing what are the dimensions available. You are showing what are the dimensions available. So that thing we can say, let me, okay. What are the dimensions available? We will be showing like this way inside bracket. So that thing we call it as the shape. Now here, consider about this matrix. What is the row number there? There are 2 rows. Okay. And how many columns? 3 columns. So you can show it as 2, 3. This thing we call it as the shape. By using the shape, we can understand how many axes were available. Now here how many components there? Just 2. So uh, the number of dimension is 2. By using the shape, we can identify how many axes or how many dimensions are available. Here 2. And here also what? How many components are available? 2. So you can say this is also a 2-dimension thing. Okay. So NDI or the rank is 2. If you multiply the components here like 3 into 3 and this 2 into 3, that thing we will call it as the size of the tensor. Size of the tensor. Size means you are multiplying the components of the shape. Shape means you are just put them in a bracket. What you are putting inside the bracket? The available components you are putting inside the bracket, that is called the shape. Okay, then the size of a tensor. Size of the tensor means multiplication of the shape, the multiplication of the values inside the shape. Size of the scalar is just 1 because it has just one number. So we'll call the size of the scalar is 1. Size of the vector is equals to the number of elements inside that vector. If it is like 1, 2, 3, 4 list, we can say the size of the vector as 4. If it is like 1, 2, 3, 4, 5, you can say the size of the vector is 5. Okay. But if it is a matrix or any other thing, you have to get the multiplications of that number. Right. We'll see now what are the examples of 1D tensors, 2D tensors like that way. Now, I have taken a small data set that I have used for previous things. So I want to check how the employee is hiring the applicants. So if it is like undergraduate level, they will consider about the current CGPA, okay, or the CGPA and the IQ level, and also the district or the state. If it is USA, they will consider the state, the San Francisco or the New York, like that way. They will consider that one. After that, the placement, whether he is selected or not. Now, suppose like the CGPA is 3.7, the IQ value is 94. This is just a one row. IQ value is 94, and the district, I have put a district here. This Sri Lanka, the district is Colombo. The Colombo means the capital is Colombo, and the district also belongs to the same name. The placement is 1. Now, how I use this one? How I use this row? Now, if you want to store these inputs, now these are the attributes: CGPA, IQ, and the district. Those are the attributes. Okay. If you want to consider these things, and this is a categorical data. If you want to store categorical data, you want to do a numerical encoding. So guys, if it is, if you can't understand about this district thing, we'll go with the state. Suppose it is like New York, inside the New York and out of the New York. You can just give a numerical value. If it is inside the New York, it is 0. Outside the New York, it is 1, or other way. If you want, you can get, you can give. If it is inside the New York, it is 1. Outside the New York, it is 0. Like that way, you can assign values for that one, numerical values. So according to that, we can store it here 3.7, 94, and 0 for this district. So it is just a list, guys. It is a list. It has 3 values. These 3 values mean It is like 3x in the vector. If you consider just as a vector, this has 3 values. 3 values means x, y, and z. So the district is one axis, CGP is another one, IQ is another. Just this is the vector notation. Okay, vector notation. It has 3 components, means 3 axes in the vector, 3 dimensions in the vector. But it is, if it is a tensor, it is a 1D tensor, and it is a list. So the meaning of this one is you can store these type of you can store these type of rows as a Python list 3.7, 94, and 0, because somehow you want to store these things, okay, for your computations in the machine learning domain. So I can store this thing as a list. Did you get that idea?
Yeah.
Okay. In the same manner, if you want to just consider about the student CGPAs, okay, then that CGPA column you can store, okay, because you will be getting various of CGPA value. That thing also you can consider as a list and you can store. So then you can do analysis according to the CGPA, the same manner IQ and the district as well. So in that manner, okay, we can use 1D tensors to store the things. Okay, that is the use of the 1D tensors. Okay, so I have given this one. Every machine learning table, each row is a 1D tensor, but it will be a multidimensional vector, because here we have considered only 3 things. But if it has more attributes, you can have more components there. Also in the machine learning problem, each column can be considered as a 1D tensor, and the column also you can consider as a 1D tensor. Now we'll see 2D tensor example. We'll consider 2D tensor example. They are also the same example I have taken, but now I have taken multiple rows. Okay, multiple rows means now this is a data set. Here like 3.9, 3.7, 3.6, and 1, 2, 3, 99, and 111 for IQs. Now for the districts, there are 3 districts. So you can give a numerical encoding for this one, and like 100 or 011. Yeah, like that you can put. Okay, if it is consider this thing is the Colombo. Inside Colombo is 1, outside Colombo is 0. So if it is Colombo 1, this is 0, this is 0. Or the other way. This is 0, this is 1, and this is 1. Like that way you can put. Okay, then you can store these things like this is one list, this is another list, now this is another. That means it is a collection of lists. What is that? Collection of lists means it's a matrix. So matrix means it is a 2D tensor. So normally a data set you can store as a matrix or a 2D tensor. A collection of 1D tensors is a 2D tensor. So collection of rows in a machine learning data set is a 2D tensor. That means normally you can store your data set as a 2D tensor. We'll see now 3D tensor example. So that I have taken example from NLP, natural language processing. Okay. You do not know about natural language processing, but I will give a brief idea about this one. What is called this natural language processing? Now, if I go to Google and if I ask about like this way, what is the best or the best university in the world? It will be best means you can't define the value, so it will be giving filter in this thing: Oxford, Stanford, Cambridge, like that way. If I ask what is the rank 1 university in the world, it mentioned as the MIT. According to the QS World Ranking, MIT is there. Now, how these things are figured out? You know that Google is a search engine, but how the exact value has filtered out, that is related to the natural language processing. Now, if I ask a question, you can answer me. Okay, if I ask a question, then how the Google answers. Okay, the Google also behaving like the human. He can filter out the process the things. Okay, process the thing from various resources and process the things and give the filter out the answers and give the exact answer. Okay, that's related to the natural language processing. Okay, so natural language processing is the higher level of the deep learning. Okay, so first of all, if you want to learn NLP, you want to learn first the what we call the deep learning. So here I have given a very short idea about this NLP problem. So we'll see. Uh, I have taken like this example. Hi, Onara, the names of some guys. Hi, Onara. Hi, Danuja. Hi, Dean. And hi, Dev. Right? Now, this is one sentence. This is another sentence. Another sentence, like there are 4 sentences. Now, I want to represent these 4 sentences. So that I have made a table. Hi, Onara, Danuja, Dean, and Dev. Now, if I want to represent hi, I will be assigned 1 for that high and the rest of the other things will be 0. If I want to represent the Onara, for Onara I will be assigning 1. For the rest of the things I will be assigning 0. If I want to represent Danuja, I will be assigning him as 1. All the other things 0. The same for Dean and same for Deul. Okay, now I want to get the idea of high Onara. How do we represent high? It is by this list 1000000. That is high. How do you represent Onara? Onara means this row. Okay. For Onara 1, other things is 0. This is this set of numbers is the Onara, or this list is the Onara. And the Danuja is this list. Dean is this one, and the Devmin is this one. Now, high Onara means high is this one, Onara is this one. Okay, so you have to get this one and this one. So, 2D array. Now, if you want to say represent all of these 4 collection of 2D arrays, that means it is a 3D array. So I can show you it here. So here, high Onara means high means this one, Onara means this one. So it is like this, a 2D array. High Danuja is also 2D array like that. Now, if you want to represent all of these things, what is that? Collection of all 2D arrays, that means it is a 3D array. Did you get that idea?
Yeah.
Okay. Then we'll move to how do you get the shape of the 3D tensor? Now you can say there are actually the 4 2D arrays. Okay, how many members in each array? Here, this thing, how many components? 5. 5, how many available of those 5? There are 2 here. In the 2D array, 2's of these 5 are available. First, take the basic thing. This is a vector. This vector has 5 components. So I have represented 5 here. And how many of those things are available in that in the matrix of that one? 2. First the vector, then the matrix, and after that you can say how many collections or 3D thing. 1, 2, 3, 4. That 4 is there. The shape you will be represented like this way: 5, 2, and 4, or 4 to 5. The size of that one is the multiplication of these things. 4 into 2 is 8. 8 into 5 is 40. Okay, that way you can get the size of the tensor. Okay, another 3D tensor example we'll take. Okay, that is the time series data. Time series data means the data uh, that you are taken in regular or the frequent intervals. Like if you are taking some data today and another set of data tomorrow, the following day, again you are taking data like that. If you are continuing, we can say it is a time series data. Or 1 second you are taking some data and then next second you are taking another data like that way. Second by second, if you are taking data, that is also time series data. Week by week or anything which has a regular uh, time span, if you are taking the data, we can consider it as a time series data. The very good example for time series data is the stock market, the share market. Okay, if you considering the stocks day by day, you can consider it as a time series data. Now, I want to consider about the stock prices. I will be no getting the attributes as highest stock price and the lowest stock price. Now, day by day, I will be collecting the stock prices. So, what is that? Now, if you take day by day, what is that? It is a data set. You are getting a data set. So, it is a matrix. Why? This is these two things you can represent as a list, and the next day also list like that way. The collection of lists. Collection of lists means it is a matrix and it is a 2D tensor. Now, after getting 1 year, so if you are getting this type of now for 1 year, if you are taking like this type of data sets and you want to get the same thing for 10 years, that means it is the parallel data sets you will be getting. Now, again, if I consider like that, day by day, if you collect data for 365 days, then it is a 2D tensor. If you continue that for 365, if you continue it for 10 years, then means it is a 3D tensor. Because why? There will be parallel matrices. There will be parallel matrices. Therefore, it is a 3D tensor. So that type of scenarios you can use 3D tensors. And 4D tensor. When you deal with the biomedical imaging or anything which is related to imaging, okay, that means it is the computer vision domain. So those data you can store as 4D tensors. So how it is happening now? Now when you consider about the image, if I say an image, I will go to the Google, and image has something called the pixel values. Pixels in image data. We'll consider this one. Consider this one. Now this is a black and white image, and those image, it is represented by some square dots here. It has some value, the size, okay, some length, anything, any number, any image, it will be represented by this way, dotted way, squares. It has size, length and breadth. Okay, that thing we will be calling as the pixel values. Okay, those are the pixel values. If you come to this thing, now the pixel values, any black and white or any one color image, you can represent it by pixel values. Okay, pixel values has two things: size, the length and the breadth, like that way. It has two values. Okay, if you want to consider colorful image, so the red, green, and blue, like this way. So then it will be like a 3D tensor. Again, if you consider just one color pixel value, okay, or the one image, it has just two things. It is like a matrix. Okay, the pixel value, only the pixel values is available. So it has a size like this type of squares. Okay, so it is like a matrix then. Okay, if you want to consider a colorful image, So you want to consider the colors as well. So colors means another set of matrix and another set of matrix. Basically, there are three colors, RGB, so that you will be getting like matrices like that way. Collection of matrices means it is a 3D tensor, so you will be getting like this way. Now, this is for one image. If you consider about multiple images, that is a collection of these three sets. Okay, collection of these three sets. That means it is a 4D tensor. That is what 4D tensor. Okay, so every image is a collection of pixels. Each pixel has a numerical value. If it is a colorful image, it has three channels called RGB. So it is a 3D tensor. So if you have multiple images, so you will be having another set of these things. So it is a 4D tensor. So this 1200 into 800 is the just the pixel value of one image, and 3 means the RGB values. So it is 3D tensor. Now, if you consider about 50 of those images, you have to consider 50 sets of that one. So the shape again 50 is also coming. Now it is a 4D tensor. Now we will consider about the 5D tensor example. For 5D tensor examples, we can take the example as videos. Actually, the videos are the moving frames of moving frames. If you consider a static image and if you allow it to move fast, we can consider it as a video. So the videos are basically frames which are moving fast. Okay, just imagine there is a one video of 60 seconds, 60 seconds of running time, and there are 30 frames per second. That means 30 photographs per second. And each has resolutions of 480 pixel. 480 pixel values. 480 pixel means 480 multiplied by 720. That is the size. 480 into 720. That is the size of the pixel. If it is a colorful image, you have to consider the color as well. Now, again, think from the beginning. Pixel value is 480 into 720. It is just one matrix. If it is a colorful image, that 480 into 720 multiplied by 3. Now it is a 3D tensor. Now you want to have 30 frames per second. Okay, 30 frames per second. So there are 30 frames are moving. Okay, and also the one video, it has 60 seconds time slab. So you will be multiplying by 60. All of those things is a 4D tensor. According to this thing, it is a 3D tensor because it's the one video. Okay, one image of 480 into 720, and it is a 3 color, so it is 3D tensor. If you consider about 30 frames per second and the video is lasting for 60 seconds, the 16 to 30 with the earlier thing, we can consider it as a 4D tensor. Now this is one video, and if you consider about multiple videos, suppose like 4 videos available, then you have to multiply it by the 4 as well. So this is then a 5D tensor. 5D tensor example you can consider as videos. Okay, now if you consider this video, okay, you have to know that the size of that video is 4 into this value. The big number is coming. Okay. If I consider that one, this big number, we'll consider just take the things. Now the earlier 480 pixel means 480 multiplied by 720. Okay. This thing we have to multiply by 3. We'll get a calculator and do here. Now 480 multiplied by 720, that is for one image pixel value, and this is now 2D tensor. You want to consider the colorful, you want to multiply by 3 RGB value. Okay, you got the answer as this thing. Okay, now this is what's 3D tensor. Okay, now you will be having 30 photographs. Okay, now what is that? The 4D tensor, and it 4D tensor, and that thing has a 60 seconds of time frame. Okay, the video time. So we will be multiplying that thing by, this thing will multiply by 30 frames, and also will multiply by 60, because one video is 60 seconds. You will be getting this answer. That is for one video. And now what is that? This is what the 4D tensor. Okay, and if you consider about multiple videos, like 4 videos of this one, this is a 5D tensor. You will be getting this type of big value. Now, if you want to store this thing in the 32-bit float values, you want to store this thing 32 bits in the 32 bits of float values. What you want to do? Multiply by 32 as well. You are getting this answer. Now you want to convert it into bytes. Bytes means 1 byte equals 8 bits. So divide it by 8. You get the answer as this way. The high value. So because of that, I will convert it to kilobyte. So again, divide by 1024. That was a big value. So I want to convert it to megabyte. Divide by again 1024. This value. I will convert it into gigabyte. So again, divide by 1024. You will be getting the answer as 27.8. Still 27.8 gigabytes. Still a big value. Still a big value. Now, according to our machine learning domain, this is the value that we are getting. But to store this type of big values, we will be doing some video encoding like MKV, MPEG, and MP4. That's why we will be converting the videos into MP4 format to reduce the size. Right. Now we'll see the next lesson, that is the framing of a data science problem. Now, if you want to convert something to a machine learning problem, earlier, the last day I have considered about the implementation. There I have talked about something called the Magic Sevens concept. Okay, any machine learning problem. Okay, the machine learning problems means that is our technical aspect. But before that, you want to understand about what is your business concept. You are converting a business concept into a machine learning concept. Okay, so that you want to have data to do that. Now see, what are our business concept? Now, according to your research also, you will be having a business concept. We'll see, according to these things, what are the classifications of this business concept. We will be considering what the human can do. According to that, how can we mimic those things? That is called machine learning. What are the things human can do? How do we mimic those things? By considering that one only, we will be understanding the business concept. We know that human can analyze, identify patterns, and make decisions. Okay, we want to mimic that one by the computer automation. So that we will be using the data. Here we can use the numerical data for that. Computer can understand these things and analyze the thing. So the technical concept is we can use machine learning and deep learning for that one. And again, the human can listen and speak. If you want to mimic that one, you can use the text and audios as the data. The machine learning, the technical concept, you can use machine learning, deep learning, and the natural language processing. These concepts you can use. And you know that human can see and human can recognize the things. So if you have given an image, MRI scan image to a doctor, he will be going through that one manually and understand by his expertise. But it will be a difficult task for him, and it is a time-consuming thing for him. So what's that? He want to do the same thing by a automatic methodology, computer-based methodology, so that we will be using the computer vision domain. Right? So that the data is the image of the video. So what is the technical concept? Computer vision and the deep learning. And the human can think. Human can understand the mindsets. So that is related to brain signal processing of the human. So if you want to do this brain signal processing of you to take the brain signals, because we will be using the concepts called, we will be using the data called electroencephalography. That is the basic thing, and there are more things, EEG data. And the technical concept will be the machine learning and the deep learning. Okay, any of your machine learning, if you want to consider anything business concept to a machine learning domain, you have to consider, first of all, you have to define what is your domain, business domain. What do you want to do? According to your scenario, you are going with the computer vision because you want to have some kind of I don't know what is that one. It is fluorescent based images, isn't it? So I think
exactly.
yeah. So you want to analyze those images automatically, and you want to identify the patterns of that one. So according to where your domain is, this one, human can see and recognize. So you want to have the image data. So you will be using computer vision and deep learning. Okay, interesting domain. You will be using that one. So we'll see how a company generates profits. Okay, if a company generates profits, we'll consider about the Netflix company. So they are, we want to consider how the company is generating profits or the revenue. There are actually three ways. One way is somehow some subscription or sales should be there to generate the profits. Okay, if it is a Netflix company, that's according to the subscriptions. Okay, if you are getting more subscriptions, you will be generates more profits. Okay, if you can't get the more subscriptions, then you want to ask more from the existing customers, but it is not a good thing because it will be a difficulty for the existing customer. And the third thing you can generate profits is minimize the churn rate. Churn rate means that there are existing customers. If they are leaving from the platform, we will be calling as it is the churning. So you can, if the people are stopped subscribing a service, we can consider it as a churn rate. So if you can reduce that churn rate, you can increase the profits. Now we'll see how to convert a business problem to machine learning problem. So I told you how to first recognize your business domain and give a mathematical aspect to that part. Okay, as an example, reduce the churn rate from 5% to 4.75%. That means you have given a mathematical meaning for that one. How to have that mathematical idea. Then only you can formulate the machine learning domain. Okay, then we can understand what type of problem is that way. What sort of problem is this? Whether it is supervised learning, unsupervised learning, or if it is a supervised learning, it is a classification or regression, like that you have to understand. So you want to understand identify the big picture. Big picture means it is the end result. What is your end product? Okay, now here, if you consider about the Netflix, your end result is you want to reduce the churn rate. Okay, then you have to consider how to reduce the churn rate. Okay, your goal is not to predict the churn rate. Okay, churn rate prediction is one thing, reducing the churn rate is another thing. So your idea is to reduce the churn rate to generate more profits. Okay, then you have to identify who are the customers who are going to leave the platform. Okay, and then if they are going to leave, so you want to make some remedies, like providing some discounts by understanding their difficulties. Okay, that way you want to go. Okay, this is the industrial machine learning. If you want to become an industrial machine learning expert, you want to understand how do you generate the profits there. So suppose like it is a supervised learning thing. This is not stealing, it is like leaving. Okay, supervised learning, you want to consider like the people who are going to leave the platform or who are not leaving. That means it is a classification. But if it is like this way, you are understanding the people who are going to leave. That means it is one thing you are focusing, and what is the percentage or probability of the leaving the platform. If you are getting just one result and you are getting a probability based on that one, then it is a regression based problem. Like that, you want to identify what sort of problem is that one. Then if there is a existing solution, that means like the company already it has a model. By that model, you can predict the churn rate. Prediction of the churn rate is you can do. It has some attributes. By using those that model, you can get the idea of the reducing the churn rate, because you can understand what are the attributes, those things, and you can build up your model. So your idea is reducing the churn rate. There is a model already for predicting the churn rate. Okay, so you can get the factors according to that. Now, how do you get the data? Okay, now people who are going to leave from the Netflix platform. Okay, first of all, you want to consider now Netflix means it is a movie platform. You can consider about their watch time. Why these guys? How many time they have watched that one? Now, people, if he is not continuously watching a video, that means he is dissatisfied. Okay, if he is fully watched the video, that means he is fully satisfied. Like that, you can come to a conclusion. Okay, according to that, according to the watch time, you can make an attribute. And the search and did not find results. Now you are searching through the Netflix website and you are not getting the relevant movie. Result is not found. That is a dissatisfaction. And if you leave the content at the middle, that is also dissatisfaction. And consider about the recommendations. Now there are recommendations are coming. You can click the recommendation. That means you are interested. You are interested about the movies. Okay, according to that, you can gather the data. Okay, you have to when you are consider about getting data, you according to your domain, you want to consider what are the data you want to take. According to that, you can consider whether your model is successful or not. How is the accuracy of the model or not? Then you want to put this into the production. When you are put it to production, you want to consider about it is an online learning or batch learning. Now, if it is the movie platform like Netflix or YouTube, it is always online, because always you are getting the data from that. Dynamically, you are getting the data. If it is like your domain, Solomon's research domain, you can use a batch learn system for that one. because it is not always changing. Is that so? It is not always changing. It is not dynamically changing your data. Is it dynamically changing? Solomon,
It's
your data
changing.
is not. Your data is it is constant for some particular time, isn't it?
Yeah,
Or
it's constant. Yeah, for some
so you
particular.
can go, yeah. So you can go for batch learning. Okay. After that, you can check your assumptions. Okay. Will your attributes available? Actually, your attributes are available that you can get the
Yeah.
data according to your attributes. You can check. After that, you can consider whether a single model is enough for my thing, or you have to have a multi-model for that one. Or these models are geographically based models. Okay, according to the geographical areas, the data or the model that you are taking is different. Like that, you can decide. Okay, then data gathering mechanisms also different. Now you can get the data from the CSV files. That is the normal way. Okay, you can go and gather the data. And normally in research we do like that way, and you can get the data like the JSON and the SQL files. And if it is not, you can fetch the data from the APIs. Okay, some websites you can take the data. The websites also, if they do not allow APIs, then you can do a mechanism called web scraping and get the data. And these things we'll learn in the next day. Okay, that's all for today. I believe that you understood the thing. So,
Yeah, I know.
okay, and try to do that implementation, and
Yeah, yeah.
okay, then it will be easy. We'll do another implementation because I want to give you a help related to this convolutional neural network. And the easy way, I will release a video. Okay, by looking that one, you do that implementation. Okay.
Okay. Okay. Okay.
Okay then. Thank you very much. Bye.